Alright guys, today I'm going to be going over module 16.1, which is log properties. This is actually one of my favorite lessons to teach in Algebra 2. I'm going to give you a quick overview of what we're doing today, and then we're going to go into the text. So the first property that we're going to learn is what we do when we have multiplication inside of this log. And so what we're going to do is we are going to split this to be log base 2 of 3 plus log base 2 of m. So that multiplication here is going to expand our logs. So see how we had one log, now we end up with two logs. We expanded it to be log base 2 of 3 plus log base 2 of m. If we were condensing it and moving back this way, then we would have two logs and we would condense to be one log. For this next property, we have log base 5 of 3 divided by x. And what we do when we have that division is we get log base 5 of 3. Well, if multiplication was addition, then division is going to be subtraction. So I'm going to subtract log base 5 of x. Something to note here is that what's on bottom is what's being subtracted. So we didn't put log base 5 of x. No, we put log base 5 of 3, right? Because that's what was on top, and then we subtracted the denominator. And then this last property is, what do you do when you have an exponent? And this exponent is actually going to come and be the coefficient. So this is going to expand to be 2 log base 4 of x. Okay, now let's dive into the text. So module 16.1, properties of logarithms. Explore 1 is on page 783, and let's get into it. So it says, investigating the properties of logarithms. You can use a scientific calculator to evaluate a logarithmic expression. Evaluate the expressions in each set using a scientific calculator. So I've already gone ahead and done this. I would recommend that you get a calculator and make sure that you can also get the same values that I do, so that you know how to use it properly. Okay, but what I did was I already found these values. So log 10 divided by 3 is 0.57 approximately. ln 10 is 2.30. Log of e to the 10th power is 4.34. And log of 10e is 1.43. For set B, again, I've already gone ahead and found these values. So I have 1 divided by log e is 2.30. 1 plus log e is 1.43. 1 minus log e is 0.57. And 10 log e is 4.34. Okay, and then moving on to part B, it says match the expression in set A to the equivalent expression in B. So I see that this one goes with this one, and so that expression is 1 minus log e. Then I have 2.3 here and 2.3 here. So ln 10 is equal to 1 divided by log e. And the 4.34 matches this one. So this one is 10 log e. And the last one, 1.43, matches with this one, and that's 1 plus log e. Alright, if we move on to the next page, which is 784, we have this very important chart for us. That's the properties of logarithms. I would go ahead and highlight this. You are going to want to memorize these. These are all very, very important. We have some definitions and how to simplify some logs using these. We have the product property of logarithms, quotient property of logarithms, power property of logarithms, and even change of base. So you're going to want to highlight these. I would even recommend getting an index card and writing them on there so that you have them for reference anytime that you're doing a review or a homework assignment. You have them handy. I am going to go ahead and move on to explain 1 on the next page, so 785. and it says use the properties of logarithms. So express each expression as a single logarithm, simplify if possible, then check your result by converting to exponential form. So if we look at this, we have a subtraction, and if we remember the properties that I went over with you, subtraction is division. So I'm going to rewrite this as log base 3 of 27 divided by 81. In fact, the book has that written for us right here. Then if we do some simplification, 27 goes into 81 3 times, so I get 1 over 3. Now 1 over 3 can be written as 3 to the negative 1 power. And when we do that, this negative 1 power can move to the front using our exponent properties of logarithm. And then this log base 3 of 3, well, that's one of the definitions on that chart that I said were really important. So this cancels each other out, and I get negative 1. Well, now it says to check your result by converting to exponential form. So the question is, does this really equal this? And if we convert to exponential form, we have 3 to the negative 1 power equals 1/3, and 3 to the negative 1 is 1/3. So does 1/3 equal 1/3? Yes. All right, for part B, we're going to go ahead and simplify this just like we did in part A. And so when we have a plus, we're doing product property of logarithms. And so we're going to take the two arguments, 1 over 25 and the 625, and multiply them together. So we're going to multiply these, and that is called product property. So when we do that, we get 625 over 25. And if we simplify that, you can think about this as how many quarters go into $6.25, or you could say 625 divided by 25, which is 25. So now I have log base 5 of 25, and we want to write it using the same base that we have here. And since we have base 5, how can we rewrite 25 as 5 to some power? So that's log 5, and then 25 is 5 squared. So what do I do with that exponent using my power property of logarithms? So I'm going to take this and I'm going to move it to the front, and that's going to go here. Okay, now remember, log base 5 of 5, well, those cancel each other out, and I get 2. So again, we have to check our work, and we have to say, well, does this actually equal 2? So let's set that up. Log base 5 of 25 equals 2. Let's see. Writing this in exponential form, we have 5 to the second power equals 25, which is what we have here. So we have 25 equals, and then 5 squared is 25. So it does check out. Now, one thing I don't like that the book does is I feel like they make this lesson a little bit more complicated than it needs to be. So let's go ahead and try these and just, try not to overthink it. So express each expression as a single logarithm, simplify if possible. So, well, first thing I see is that what can I do with this exponent here? I can use my product property, my exponent or power property. That's why it's nice to have those handy dandy properties next to you. I can write that in the front as my coefficient and say log base 4 of 64, and that 3 is in the front. Okay, multiplying. So now I want to write this as the same base of 4. So I have 3 log base 4, and then how do I write 64 as base 4? So 4 times 4 is 16. 4 times 4 times 4 is 64. So to rewrite this, I would have 4 to the third power. Okay. Now, anytime there's an exponent, what can we do with it? We bring it to the front. So I have a 3 here. And now I have 3 times 3, which is 9. Now 9 log base 4 of 4. And remember, these cancel, so I get 9. So we were able to simplify this expression to be 9. For number 5, Well, I see subtraction, and I have my properties next to me, and so I'm going to use the quotient property and rewrite this as log base 8 of 18 divided by 2. So 18 divided by 2 is log base 8 of 9. Now I want to write 9 as base 8, but there's nothing that multiplies, like it's not 8 times 8 will give me 9. Nope, that's 64. 8 to the first power, 8. So there's no base 8 that I could write here. So if I'm looking at my properties, I have change of base. So change of base allows me to write this as log base 9 over log base 8. And now I've changed these bases to be 10, right? This is just log base 10 of 9, log base 10 of 8. And then I can actually plug this into a calculator and solve this. So let's see. I'm using my calculator, and you should try this yourself. Log of 9 divided by log of 8 equals 1.06. I'm going to go ahead and round it there, so maybe I should actually use these. This is approximately. Alright, now I'm going to go back to where I introduced my log properties to you, and we're going to try a couple examples. So let's try example 1, and let's say that it says condense. So if I have log base 2 of x plus log base 2 of 3 plus log base 2 of y. Well, how would I condense this? So I have 3 logs. They're all the same base, so I can go ahead and use this product property, and I can multiply the x, the 3, and the y. So I'm going to get log base 2, and if I multiply x, 3, and y, I get 3xy. Bless you, little Ashley. Sorry, I've got my daughter next to me. Alright, let's try another example. Let's stick with condense, and let's condense log base 4 of x minus log base 4 of 3. So I have subtraction. I'm going to condense these to 1 log base 4, and I get x divided by 3. Alright, another example, so the example 3, I guess. Let's go expand. So let's go the other way. What if we have log base 3 of x squared over, actually let's go 2x squared over y. Alright, well first I know that I can expand this division to be subtraction. And so I would have log base 3 of 2x squared minus log base 3 of y. Okay, now how do I expand this? Well, I'm going to expand this multiplication, or this product, using my product property. So that would be log base 3 of 2 plus log base 3 of x squared. And then we still have the minus log base 3 of y. And now this exponent, that's the last thing I need to expand. So I have log base 3 of 2. Let me write that a little neater. So log base 3 of 2 plus, and we're bringing this 2 to the front of the x term, or the logarithm with the x squared. So I'd get 2 log base 3 of x minus log base 3 of y.